This is Expert Funda and you are watching today Leetcode question on the YouTube. So the first question that we have today is 35, okay, of the Leetcode question, in which we are going to see the search insert of position, right? So let's understand the given sorted array of distinct integer and target value. So the what we have given, some distinct integers gave him array sorted, right? Sorted, what we have given, oh sorry, let me go back. Yeah, so we have given a sorted array of distinct integers and target value, and we have to return index that if the target is found. uh, if not, we will return the index that would be if it will insert the order, right? It will insert in order. So write a function, that algorithm, that O log n time complexity we have to do, and it will work. Okay, so this is the things we have given. Target is 5, right? So index we have given already. So we have to return the, you can say, insert position we have to return. Okay, so what we have given, we have sorted array given like this. We have given nums and a target value, that is we have given this one. We have to return the index if target is found, right? And if not, then return the index where it would be inserted in order. Okay, and we have to use O log n time complexity. This question is asking the many interview questions. So what do you have to do? We have to, let's suppose we have given the first one, 3, 5 and 6 we have given, right? So if 0, 1, 2, 3, these are our indexes, right? So 2 is the index that we have found. The target, our target is 5, right? That we found. So that we are returning this one. Next what we have, 1, 3, 5, 6 we have given, right? Like this, 0, 1, 2, 3. So 2 we have to find. So target we have given is 2. So where we should insert? So we should insert here, this position, right? Next what we have nums we have given this one, 1, 3, 5, 6, 7 we have to insert, right? So now if you'll see, we have to we can insert here this position, next position, right? That is this one, that is will come here 7. Okay, so if we already have the data, right? Let this was the list what we have seen till now. If we have already the list data we have given, and big data we have given, like if you want to add 2, right? If you want to add into between 1 and 2, right? 1 2, so this will come here, right? In between that, right? So what will happen, this will get shifted here, right? So it will become 1 2 3 5 6. This will become like this one for this one, right? Okay, and if we'll talk about this one, so it will become what, 1 3 5 6 7. The new array will become like this one. So you have to find the correct you can say insert position. Similarly for this one, it will become what, 1 3, next insert 5 5 6. So we actually, what it is saying, if not, right, then return the index if target is found, if target is found. If not, right, if not, the, like, sorry, in this case there is only 5, right? So if not, then we will return the index. There would be if it where we inserted in the order, right? So where it will insert, that we have to return. If you find the target, that's fine. Okay, search the insert position. So what we will do, these are the constant we have given. All nums contains distinct value sorted in the ascending order, and like this we have given, right? So this question has been asked in fine companies, right? So this is very important questions, right? So what we can do, we can say that we will use the breadth first search, right, approach. Sorry, binary search, right? We will use binary search. We will use the binary search approach, in which we will see right, we can see that it could be a good match with the binary search algorithm, right? So binary search algorithm that find the position of the target value within a sorted array, right? And usually with the binary search we compare the target value to the middle of the element of the array at each iteration. If the target value is equal to the middle element, the job is done. If the target value is less than the middle element, we will continue to search on the left, right, we used to do, right. If we have array 1 3 5 6, let's suppose. So what we will do, we will find if the target is equal to the middle, right. So what we'll do, middle, if this is left and this is right, so middle will get what, how, left plus right by 2. Either we can do that and we'll get our this one. So if left is at 0, right is at what, 3, 0 0 1 2 3, we'll do by 2, means 3 by 2 equal to 1, means this is our mid, let's suppose. Okay, so if the target is equal to the middle of the this one, if we'll find this target, this is the target, let's suppose, then our job is done. If the target is less than the middle, right, if the less than this one, so we'll go to find here in this position, right. If this is greater than, then we will find here, right, like that. If the target is greater than this one, then we will find in the continue the search, right, we will do the searching. I think you understood, right. So what we have to do, we have to find the, we have to actually find the we have to find the, you can say, boundaries, right. So to mark the each search boundary, right, what we will do, we will use two pointer left and right, like this we have seen, and then we will use length left equal to 0, sorry, index of left is 0 and right is n minus 1, you can say, correct. If we'll talk about, give me 1 minute, I'm changing the color. Okay, so we will use this is left, this is our left is at 0 and this is at what, n minus 1, the size, right. And then we will move either of the pointer, like left is less than equal to, while left is less than equal to right, then we will move like this. We have to find the pivot, right. So what pivot is it, right. Pivot is nothing but a mid, right. So if we are talk about this one, mid you can say, or pivot, right, both are exactly same, right. So if we can calculate like this, how pivot is left left plus right minus left by 2, right. So what we will do, we'll do this one and then we will find out this one. Another way to find this one is what, we will use we can use in Java, what we will do, we'll do there is a right, I think there is a right, I think right plus left will do, and we use right shift of 1 and you will get the, so this approach is faster than this one. Okay, I think you understood. Let me clean one. So if you find, if you want to use find the pivot, right, you can use what, left plus right minus left by 2, let's suppose. Otherwise if you want to use a faster way, you can use what, right plus left and you will use right shift, right, like this is faster than the this one. So this is the you can say bit more complicated, but probably faster than the bit shift operator. Okay, so bit shift operator is better okay. Now what we will do, we will do the understanding using the binary search, right. So let's understand the binary search. Okay, so what we will do, first of all, we have given what, nums we have given and target we have given, right. Nums is like 1 3 5 6 we have given, this is our num, let's suppose, and 5 is our target, right. So we have to find target here, so that 0 1 2 3 is there, so we have to return 2 here, right, to answer. So we'll take a pivot, left at 0, right is num minus 1, num length minus 1. Then what we will check, while left is less than equal to right, right, means it will come, if we will left is less than equal to right, means both at that position, right should be greater than equal to left, then we will stop. we'll find our pivot. Either we'll do here you can use also what I talk about, right plus left, and we'll use the with shift operator 1, right? You can use also here. Then if num of pivot is equal to target, num of pivot is equal to target, we will return our pivot. Okay, and if target is less than pivot, then what we will do, pivot right equal to pivot minus 1, and if left equal to, if else left equal to pivot plus 1. So if pivot is at the mid of the element, means we have find our target, we will return this one. Otherwise we will go left or right. Either if this is a pivot, right, 3 is pivot, right, if target is 3, we will get the target here, we will return. If not less than, means we will go to here, this side. If not, then we will go to this side, right? And finally we will return our left, right, and we are actually updating our value, right? So we will return our left, and then that is our answer. Okay, so in this way you will find our solution, and if you have any doubt, you can ping me in the comment box. Okay, so if we'll talk about the complexity, right, so time complexity for this one will come O log n. Okay, and for a space complexity it will become O of 1, right? So why O log n is coming, time complexity? So let's compute the time complexity with the help of, you can say, master theorem, right? Let's suppose master theorem is t of n, right? So we used to do at n by b, correct, plus there was a theta, sorry, there was a theta, and we used to do n to the power d, right, this one. So this equation represent dividing the problem into uh, this this number of sub problems, a you can say sub problems, right, sub problems, right? So this represents a sub problems of size what, n by b, correct, in what time, in theta of n to the power d times, correct. So here at uh, each step only one sub problem, like a equal to 1 of its size is v equal to 2 for all d equal to 0, right? Means for each step one sub problem a equal to 1, right, and if is there, and its size is half of initial problem, means b equal to 2, and it takes all the time d equal to 0, right? So if you do the result, it will become, right, it will become log base a equal to d. So we will replace this one with what, o there was n log base b a log d plus 1 and n, right, like this. And so it will become what, o log n, correct. This is the time complexity we will get. And there is a space complexity, it will take, we are not taking any extra space. So O of t is the, O of 1 is the space complexity. So I think this video is enough for the discussion. So if you like this video, please hit comment and subscribe this channel. If you like to drop any questions, please ping me in the comment box, so that I'll help you there. Thank you so much guys. If you like this video, please comment, subscribe.